Download this code from codegive.com, link in the description below. OK, let's dive into a detailed, 9-step tutorial on recovering from a Proxmox VE boot disk failure. This guide assumes you're using ZFS, which is the recommended and most common setup for Proxmox, for your boot pool. It also assumes you have access to another machine to prepare the recovery environment. Important considerations before you start. Data backup is critical. This guide focuses on recovering the Proxmox OS. The most important thing is to have a solid backup strategy for your VMS and containers. Restoring from a failed boot disk without backups is a recipe for data loss. Regularly backup your VMS/containers using Proxmox's backup tools or other suitable solutions. Identify the failed disk. Determine which disk has failed. This is crucial to replace the correct drive. Check the Proxmox web interface, if you can still access it partially, the system logs, if accessible, or the BIOS/UEFI. If you suspect a disk, physically examine it if possible. Understand ZFS replication. Optional if you're using ZFS replication to another pool/server, the recovery process is much simpler. You can promote the replica to become the primary. This guide doesn't cover ZFS replication specifically, but it's a highly recommended setup for production environments. Hardware compatibility. Ensure the replacement disk is compatible with your server. Use the same type, SSD is highly recommended, interface, SATA, NVMe, etc., and a similar or larger capacity as the failed disk. Safety first. Power down the server completely before replacing any hardware. Disconnect the power cable. Follow proper ESD, electrostatic discharge, precautions. The 9-step recovery process. Step 1. Prepare a Proxmox VE installation environment, USB drive. You need a bootable Proxmox VE installation medium. This allows you to boot the server into a rescue environment and perform the recovery steps. 1. Download Proxmox VE ISO. Download the latest stable Proxmox VE ISO image from the official Proxmox website, https://www.proxmox.com/n/downloads, https://www.proxmox.com/n/downloads. 2. Create a bootable USB drive. Use a tool like Rufus, Windows, Etcher, Cross-Platform, or DD, Linux/Mac OS, to create a bootable USB drive. Using Etcher, recommended. Download and install Etcher, https://etcher.balena.io/ https://etcher.balena.io. Select the Proxmox VE ISO image. Select your USB drive. Click Flash. Using DD, Linux/Mac OS, be extremely careful. Important DD warning. Using DD incorrectly can overwrite your hard drives. Double check the drive identifier very carefully. Step 2. Replace the failed disk. 1. Power down. Shut down the Proxmox server completely and disconnect the power cable. 2. Open the server. Open the server case and locate the failed disk. Refer to your server's documentation for specific instructions on accessing the hard drives. 3. Replace the disk. Carefully remove the failed disk and install the replacement disk. Ensure it's properly connected to the SATA/SAS/NVMe controller and power supply. 4. Close the server. Reassemble the server case. Step 3. Boot from the Proxmox VE installation USB. 1. Insert the USB drive. Plug the bootable USB drive into the server. 2. Enter BIOS/UEFI * power on the server and enter the BIOS/UEFI setup. The key to press varies, usually Del, F2, F12, ESC, or something similar. Check the boot screen. 3. Change boot order * change the boot order to prioritize the USB drive. Save the changes and exit the BIOS/UEFI. 4. Boot from USB * the server should now boot from the Proxmox VE installation media. Step 4, enter the Proxmox VE rescue mode. 1. Proxmox VE boot menu * you should see the Proxmox VE boot menu. Select rescue boot. 2. Enter rescue shell * after a few moments, you'll be presented with a command prompt. This is your rescue shell. Step 5, identify the ZFS pool and disks. Before proceeding, you need to identify the ZFS pool name and the available disks. 1. List ZFS pools *. This command will show you the status of your ZFS pools. Look for the pool that contains your root file system, usually named rpool, pool, or something similar depending on your installation. Note the pool name. It will also likely show the degraded or failed drive. 2. List available disks *. This command lists all block devices, disks, on the system. Identify the new replacement disk you installed. Note its device name, example/dev/sda, /dev/sdb, /dev/env0n1, etc. Be absolutely sure you identify the correct disk. Important * double and triple check that you've identified the correct disk. Using the wrong disk in the following commands will destroy data. Verify size, serial number, or other identifiers if possible. Step 6, replace the failed disk in the ZFS pool. This is the core step. You'll use the zpool replace command to tell ZFS that the failed disk has been replaced. 1. Execute zpool replace *. Replace rpool with the actual name of your ZFS pool. Replace failed _disk _ID with the disk ID of the failed drive. This is usually something like WWN0x5000C581F907B or ATA1000DM0039YN162_S1D0M4XF, but you can also try the path such as /dev/disk/ATA1000DM0039YN162_S1D0M4XF. This will be printed on the output of zpool status. * replace new _disk _ID with the device name of the replacement disk, example /dev/sda, /dev/env0n1. Example *. This command tells ZFS to replace the failed disk identified as WWN0x5000C581F907B with the new disk /dev/sda. ZFS will start resilvering, copying data from the remaining healthy disks to the new disk. 2. Consider partition table if required *. Sometimes the new disk might not have a GPT partition table. This is common if the disk was previously used. If this is the case, the zpool replace command might fail. In such cases, create a new GPT partition table on the replacement disk using disk. Here's how. *type O to create a new empty GPT partition table. *type Y to confirm. *type N to create a new partition. Accept the defaults, first sector, last sector, partition type. The default creates the whole disk. *type W to write the changes to disk and exit. *type Y to confirm. After this, repeat the zpool replace command above. Step 7, monitor resilvering progress. ZFS resilvering can take a significant amount of time, depending on the size of the pool and the speed of the disks. You can monitor the progress using Z-pool status. Replace pool with your ZFS pool name. The output will show the percentage of resilvering completed, the estimated time remaining, and any errors. Important asterisk: do not interrupt the resilvering process. Doing so could lead to data loss or further complications. Step 8, optional, verify the bootloader, grub, installation. In some cases, you may need to reinstall the bootloader, grub, on the new disk. This is particularly important if the original boot disk was completely failed. If your system boots fine after resilvering, you can skip this step. 1. Mount the root file system *. Mount the root file system from the ZFS pool. This will differ depending on how your installation is set up. First, find the correct dataset to mount. Then mount it. 2. Mount necessary directories *. 3. Root into the mounted file system *. 4. Reinstall grub *. Identify the disk to which you need to install grub, usually the disk you replaced, /dev/sda in this case. If your replacement disk uses uefi, you might need to mount the EFI system partition first and use grub install target equals x86_64 EFI directory equals /boot/EFI bootloader ID equals Proxmox. 5. Exit root *. 6. Unmount file systems *. Step 9, reboot the server. 1. Remove the USB drive *. Remove the Proxmox VE installation USB drive. 2. Reboot *. Reboot the server. 3. Check boot *. The server should now boot from the repaired ZFS pool on the new disk. 4. Verify functionality *. Log in to the Proxmox VE web interface and verify that everything is working as expected. Check your VMS/containers and ensure they are running. Important notes and troubleshooting *. Errors *. If you encounter errors during the Z-pool replace command or other steps, carefully examine the error messages. They often provide clues about the problem. Common issues include incorrect disk names, partition table problems, or ZFS pool inconsistencies. ZFS version *. If your Proxmox VE version is significantly different from the installation media version, you might encounter compatibility issues. It's generally best to use a Proxmox VE installation media that's close in version to your installed system. Data loss prevention *. If you're unsure about any step, it's always best to seek advice from experienced Proxmox users or ZFS experts. Incorrect commands can lead to data loss. Boot pool versus data pool *. This guide assumes your Proxmox installation, the OS itself, is on the ZFS pool you're recovering. If your VMS/containers are stored on a separate ZFS pool, their data should be unaffected by the boot disk failure. However, you may need to reconfigure them within Proxmox VE after the OS recovery. Multiple failed disks *. If you have multiple failed disks in a RAIDs configuration, the recovery process becomes more complex, and data loss is more likely, depending on the level of redundancy. Consider automation/DR*. This is a manual process. For production, you should strongly consider automating parts of this or having a proper disaster recovery plan with ZFS replication. This guide provides a detailed approach to recovering from a Proxmox VE boot disk failure using ZFS. Remember to prioritize data backups and exercise caution when working with ZFS commands. Good luck.